This is Euclid Book 6, Proposition number 22, Part 2. And as you'll see here, I had to draw another figure on this thing in order to do this proof correctly. Okay, so we're going to resume here. It says, next, let MF. What is MF? Okay, now, MF is this one right here, this parallelogram MF. Let MF be to NH. Now, what is NH? This is NH right here. So we're going to have a proportion. As this is to this, let KAB be to LCD. KAB, LCD. As this is to this, so as this is to this. Okay. I also say that as AB is to CD. Well, here's line AB right here. Here's line CD right here. As this is to this, okay, so is EF to GH. EF, whoa, GH. As this is to this. As this is to this, so as this is to that. And we're talking about the lines AB, whoa, CD, EF, and GH. So far, so good. For if EF is not to GH, as AB is to CD, so if this is not to this, as this is to this, let EF be to QR. Well, where's QR? QR is right down here, people. This is QR right here. Let EF be to QR, and I'm going to go ahead and turn this fan off real quick. Oh. There we go. Now you can hear me a little bit better. Let EF be to QR, let this be to this, as AB is to CD, as this is to this. This line right here and this line right here. Okay? And this is by Euclid Book 6, Proposition number 12. So what we have done is we've drawn this line QR, and EF now is to QR as AB is to CD. And on QR, let the rectilineal figure SR, this is SR, this is the rectilineal figure SR, be described similar and similarly situated to either of the two, MF or NH. So it has to be similar either to this or to this. And this is by Euclid Book 6, Proposition number 18. Since then, as AB is to CD, as this line is to this line, so is EF to QR, and there have been described on AB and CD the similar and similarly situated figures KAB and LCD. Well, KAB is this triangle, this whole triangle, and LCD is this triangle right here. And what we've done is we have made this triangle out of this line right here, this triangle out of this line right here. And on EF and QR, well, here's EF right here, here's QR right here. We're going to make the similar and similarly situated figures MF and SR. Well, this is MF here and this is SR here. Okay, we're going to make this figure right here. We're going to make this figure right here. Therefore, as KAB is to LCD, so is MF to SR. So as this figure is to this figure, so as this figure is to this figure. But also by hypothesis, as this figure here, KAB, is to this figure here, LCD, so is MF to NH. Okay? Therefore also, as MF is to SR, as MF is to SR, so is MF to NH. And this is by Euclid Book 5, Proposition number 11. Therefore, MF has the same ratio to each of the figures NH and SR. So as this is to this, so as this is to this. Same ratio. Therefore, NH is the same size as SR. This is by Euclid Book 5, Proposition number 9. But it is also similar and similarly situated to it. So therefore, GH is equal to QR. Okay, line GH here is equal to line QR here. Okay. And since, as AB is to CD, as AB is to CD, so is EF to QR. EF to QR. while QR is equal to GH, well, first of all, let's go back a bit. As AB, the line here, is to CD, the line here, so is EF, the line here, is to QR, the line here. And while QR, this length here, is equal to GH, therefore as AB is to CD, so is EF to GH. And that's the proof. Alright. I will tell you more in a future video, so stay tuned.